Hello guys and welcome back to CS with Mr. G. We are currently in Unit 3 looking at hardware devices, and today we are going to focus on primary storage and how data is stored in the computer system when it's in use and what this term primary means when it comes to storing different types of data. As you can see, our main focus is to understand what is meant by primary storage, which includes exactly what it means, the different types of primary storage, and why these different types of storage are classed as primary and not secondary. So by now, my students tend to have a little bit of knowledge about parts inside of a computer, which includes the basics such as RAM, ROM, the hard drive, SSD drives. But if you haven't, I'll try my best to explain from the absolute bottom as if you don't know what the devices are already. So first and foremost, the definition of primary storage is a type of storage or memory which is directly accessed by the CPU. So that's the definition of primary storage as a whole, and the different types of primary storage that we'll look at all talk to the CPU directly. There's no middleman involved, and data is transferred directly from a primary storage device to the CPU. So as we know, the CPU is constantly processing instructions and data, so primary storage also stores data that is actively being processed. So just like the CPU is processing this data, primary storage is the place that it's being stored. And we will look at the different types of storage devices where this data is being stored as it's being processed. So the two main types we need to look at are RAM and ROM. And like I said, I'll explain these types of storage as if you know nothing about them. Starting with ROM. And ROM stands for read-only memory. So a little clue, read-only means that this type of storage can only be read from. Okay, we cannot put data on it. It can only be read. Now what this means is that when this little chip here is actually made in the factory, the ROM is installed with data by the manufacturer from the very second it's made in the factory. And what this means is that ROM isn't a device that you buy individually. When you buy a motherboard or just buy any type of device such as a laptop or a tablet, the ROM is already installed to the motherboard or inside this device, and again it's installed by the manufacturer. You would not buy a piece of ROM. It's pre-installed. And the reason for this is because it only contains the data which the computer needs in order to start up. So you'll probably recognize these screens from when computers are starting up. And why companies do this is that they display you a nice graphic so that in the background the computer is reading the ROM, okay, also known as the BIOS, which are just the instructions on how to start up. So getting everything ready, getting all your files prepared, doing the basics so that your computer or your phone or tablet is ready to use once it switches on. And what I compare this to with my students to make it easier to remember is it's just like you getting up in the morning. Every day you get up out of bed, you follow the same instructions in order to switch on or start up just like a computer. So our instructions would be a little bit different obviously, but we get out of bed, we wash our face, brush our teeth, have our breakfast, or whatever order you do it in, but we tend to follow the same instructions when we get up. Now the reason why I compare this to us getting out of bed is because ROM is non-volatile memory. So this term non-volatile is very important when it comes to the syllabus. Non-volatile is a term that you have to describe and also a category of storage that we have to label different storage devices, whether it's non-volatile or just volatile. So what non-volatile means is that the data on a non-volatile device will not be lost when the computer is switched off. So when the computer loses power, it's switched off, it's shut down, the data will never be lost from a non-volatile device. And the clue here is to think of the word non. If we take NO, which spells no, it will not lose data. So no, it will not lose data. And again, another tip that I use to make sure students remember the difference between non-volatile and volatile. So no, it will not lose data. So as ROM only stores instructions to start up, these aren't huge lines of code. It's just simple instructions like getting the start menu ready at the bottom of your Windows device or getting your apps ready on your Apple device on the home page. So because of that, ROM is typically measured in megabytes and doesn't require a huge amount of storage in terms of size. So it's a tiny chip that lives on the motherboard and it just stores the startup instructions, which are also known as the BIOS. You'll also hear the word bootstrap. So bootstrap is another term you'll hear for what's stored in the ROM. And again, it just refers to the BIOS or the instructions to start up the computer. And just before we move on, again, the reason why I talk about getting out of bed is that when you go to bed, if we imagine this as turning the computer off or losing electricity, you don't forget how to wake up the next day. So the instructions of getting up out of bed and washing your face and so on and so forth, you don't forget this every time you wake up, just like your device doesn't forget how to start up when you switch it on. Next we'll move on to RAM, and if you didn't know, RAM stands for Random Access Memory. So this term random, we don't really need to worry about, but the main purpose of RAM is to store any data that is currently in use, or a perfect description of what RAM stores in a computer. So data that is currently in use. That includes the operating system and any applications or programs that are being run at that moment in time. So for example, right now, I've got my PowerPoint open, which you can see. I've got screen recording software running, and there will be a bunch of tasks in the background, all done by the operating system, and all of this is being stored in RAM. So everything that you're doing at that moment in time is being stored in RAM. If you're just watching YouTube on your phone, YouTube will be in the RAM. Now RAM is the opposite of ROM in terms of its volatility, which means that it will lose the data when the computer is switched off. So for example, if you're on your phone now, you're on YouTube, the YouTube app is open, it's in RAM. If your phone ran out of battery or you manually switch it off, when you charge it up or switch it back on, YouTube will not be open. That's because it was being stored in RAM when it was being used. It lost power, so therefore it would have came out of RAM. So that's what the term volatile means. It will lose the data when the computer is switched off. And that's why generally, if your computer starts to run slow and you give it a reset or a reboot, it will start to work quicker again because it refreshes and starts from scratch. Now with this in mind, the more data that we have open at one moment in time, more RAM will be in use. So for example, if you have a Google Chrome window open or just any web browser in general, each tab that you have open in this browser occupies a space in RAM. So if you start to open lots of tabs, the more RAM is going to be in use until the point where the RAM runs out of space. You'll notice that the computer will start to run slow. And the same thing applies for just applications in general. If you have lots of applications open or programs open, the more RAM will be in use at that moment in time, which means the more RAM that you have, the more programs that you can have open at the same time. And that's the most important thing, is that it's all at the same time. Data that is currently in use, if we go back to that point, is what RAM stores. So that's why RAM is measured in gigabytes. And typically in 2025, you wouldn't really see a device with less than 8 gigabytes. Typically 16 gigabytes is a decent amount. But as we move forward in time and technology advances, we are starting to see devices with 32, 64, or even a lot more for more powerful computers. That's why really memory intense applications such as film editing or games with really in-depth graphics, these will run more smoothly on devices with more RAM because they require a lot more storage when it's being used. So I've tried to explain that as if you have no knowledge of RAM whatsoever, and hopefully it's made a little bit of sense and we can define the characteristics of RAM. Quick summary of the differences. As we said, RAM is temporary, it's volatile. ROM is permanent, it's non-volatile. So ROM is permanent, it will never lose the data installed to it. RAM will the moment that you switch off the computer. There's those two terms again, volatile and non-volatile. RAM, as we can guess, can be written to and read from. So we can choose what goes into RAM because simply by opening a program or application, that will then go into RAM. So we can choose what goes in it. ROM, on the other hand, cannot be altered, it's read-only. It's installed by the manufacturer, and us as the user cannot alter what's going on inside ROM. RAM is used to store data, files and programs, and the OS currently in use. So that word currently being used again, very important. ROM stores the BIOS and other data needed to start up, also known as the bootstrap. RAM can be increased in size if you need to improve the speed of your computer, if you're starting to run more intense programs. But typically in a device such as a tablet or a laptop, you can't easily increase the RAM as manufacturers don't like you to open up and start messing with the insides of laptops and phones and all the rest of it. A desktop PC can easily be amended and RAM can be easily increased and installed. ROM is something that you wouldn't change, you don't need to change, and again, it's on the motherboard. So as we said, it's directly accessed by the CPU. I just want to make that point really clear. And I also wanted to mention that cache, which has been discussed in the CPU lesson, also in Unit 3, also falls under the category of primary storage. So cache memory, if we think back to the CPU lesson, serves a similar purpose to RAM, but it's a lot smaller and it only contains the instructions or data frequently being used. So I won't go into too much detail about cache because it's been covered, but it does fall under the category of primary storage. So I just thought I'd make a point of that, just so you know that there are more options when it comes to labeling types of primary storage. Next, I just want to go through the steps involved with RAM, and I want to imagine that you're switching on your computer from being completely off. As we know, RAM is volatile, so we can imagine that RAM is completely empty as soon as we switch the device on. So we switch it on, the ROM is being read, the startup instructions are telling the computer what to do. The OS is transferred from the hard drive into RAM. Now, we haven't discussed secondary storage yet, so don't worry too much about the hard drive. But what's important is that the OS, the operating system, is stored in RAM because it's currently being used. As we can see, RAM here is starting to fill up. It's got the OS inside already. The computer comes on, we open some programs, we open Google Chrome, we open Adobe Photoshop. These are also stored in RAM as they are being used. Any documents or data that these programs hold, so for example, if I open an image in Photoshop, this will also be stored in RAM. And when I start to open websites and web pages in Google Chrome, these will also be stored in the RAM. They are all documents, data, and programs, all in use, so they are being held in RAM. And as you can see, we don't have much space left here. So when this happens, if we try and think in reality what actually happens here, when you open lots and lots of programs and RAM starts to get full, there's a few different scenarios which could occur. The first one is that the computer will simply start to run slow. I mentioned before, if you open lots of tabs within Google Chrome, you might notice your computer or phone starts to run slow. Also, if you just kept opening more and more programs, they're not going to fit in RAM anymore. And again, the computer will simply just start to run slow. Slow enough that it comes to a halt, and your only option is to reset, where RAM will be wiped and start from scratch. The other option is that the computer uses what we call virtual memory. Now, this is another term that we need to show knowledge of, and virtual memory ties into secondary storage as it uses the hard drive to store data. Now, the key is in the name virtual. It's something that isn't real. And what we have to imagine is that the hard drive is virtually acting as RAM. Okay, I've put acting here, act. And what it does is it uses a very small section of the hard drive, typically a few gigabytes, to act as RAM. So the computer will think it has more RAM available. That way, when we open more documents, as we can see, we've opened Microsoft Word here and a Word document within the program. It's now being stored in the hard drive, however, it's virtually behaving as RAM. So the computer thinks that it has more RAM, and what this allows is the computer to continue functioning as normal. The last thing we want is when the RAM gets full here, is that the computer crashes and comes to a halt. That's the last thing that we want. In that scenario, we're going to lose data and generally just become frustrated. So if the computer has a backup plan, and can use this temporarily just so we can continue working, this is an ideal solution to make sure data isn't lost and we can continue working as normal. So virtual memory is the hard drive acting as RAM so we can continue to work and store more programs and data in what we call primary storage. So just to finish off, some basic questions, just to recap on what we've covered. Question 1, what does RAM stand for? Random access memory. What does ROM stand for? Read-only memory. Name one difference between RAM and ROM. Well, we could mention that ROM is non-volatile and RAM is volatile. Another trick I like to tell students, if they forget, is that ROM has the letter O and so does non. So ROM and non, they sound similar and they've got an O in the middle. So if you remember the O in the middle, ROM and non, you can remember that ROM is non-volatile. And remember, you need to link this back to no, it will not lose the data. So it will not lose data. In other words, it's permanent. Question 4, how much RAM is typically available in a modern personal computer? So in a modern PC, like I said, minimum 8 gigabytes. You could have 16 if you play games. Or if you're a power user and you edit 4K videos, you might need more, 64 gigabytes or even more. And the last question, I'd like you to try and use some logic and think, why is virtual memory slower than RAM? And the reason being is that RAM, if you remember, is primary storage, which means it directly communicates with the CPU. So it's very quick. Virtual memory uses the hard drive, and the hard drive isn't as fast as RAM, which means that when data's in there, it won't perform as fast than the data being stored in RAM. So we've not really spoken about data transfer speeds, but that will be the reason why virtual memory is slower than RAM. More of that will be discussed in the next lesson, which is secondary storage, and we'll cover more of it there. So as always, guys, I hope you've managed to follow along, and I hope everything's made sense. If not, drop me a question in the comments below, and I will hopefully see you in the next lesson.